All right, so now we're going to look at the last part of our lesson of our unit. And this is now, we've done moles, we've seen how we can move it to masses and molecules. We saw how we could figure out how much um, of a component we could make or need in a reaction based on another component. We figured out um, how much a particular element is in a compound. That's our percent composition. We figured out percent hydrate if we're dealing with something that has water in it. Now we're going to look at empirical and molecular formula. Empirical formula is the formula, chemical formula in its simplest forms, which means we've reduced it down. Okay, and then the molecular formula is when we have something like a C6H12O6. If you could that could be reduced down, but because we're looking at a specific molecular mass, we don't want to do that. So I'm gonna show you a little bit of that when we get to molecular formula. But let's take a look at empirical formula because that's gonna be really important for us later on. So again, it's the reverse of percent composition. So percent composition said, here's my compound. What percentage of this compound is element A? Okay. Okay, so we have our chemical formula. What's the percentage of each element? And in this case, we did water. 11.21% is hydrogen. 88.79% is oxygen. To do empirical formula, they're going to give us our percentage first. Okay, so they give us 27.29% carbon, 72.71% oxygen. They're asking us to figure out the chemical formula for it. And this is in its simplest form. Again, we're not having things that could be reduced down. Okay, just like in a fraction, you reduce down to where you can't divide into it anymore. That's the same thing here. So your steps, you're going to determine the number of moles in each element. If you are given a percentage, you are going to convert that to grams. And the way to do that is just to make the assumption that it's out of 100 grams. So you're going to change your percent sign to the letter G for grams. So in this case, it says 25.31% magnesium. That's 25.31 grams of magnesium. Okay. If we have grams, then we're going to convert to moles, and we're going to talk about what you're going to need to do that. You already know that, though. I think you do. Think about how you go from grams to moles in any of our conversions, and I bet you know what we're going to use in step one. Then, once we figure out our moles, we have to determine which one's the smallest. Okay, we're going to take that one. Okay, and the reason I'll tell you why we take that one in just a second. We're going to take that one and we're going to divide it into everybody to make ratios. And once we figure out that division, we're going to, as long as we have whole numbers, that's going to be our subscripts. If we don't have whole numbers, then we're going to have to multiply until we do get a whole number. And here's the thing, because remember, our subscripts have to be whole. It's not like you can't have carbon 1.33 for a subscript. It has to be whole. So we are going to have to do some multiplying to get there. And so we would have to multiply everybody, but we'll talk about that. So again, I'm going to do 25.31% magnesium and 74.47% chlorine. Okay, so I have my steps. So I determine the number of moles for each element. Okay, if it's percentage, we're just going to convert it. And then once we have grams, we're going to convert to moles. So then we're going to divide by our smallest number. Okay, and we're going to see that as a ratio. It has to be a whole number. Okay, and if it's not, we're going to multiply until it becomes whole. So I have magnesium. Okay, it's at 25.31%, and we're using its molar mass, right? Because that's how you're converting from grams to moles. I know you know that because we talked about it over the last several lessons. But you have your molar mass. You're going to do the same thing with chlorine. It's 74.47%, and it has a molar mass of 35.45 grams. Okay, and you're going to literally just take your percent sign up here, and you make it grams, and you're going to multiply it by 1 mole. okay, and divide it by its molar mass. And we know this because you could do a fraction chart to do the same thing. Okay, so 25.31 divided by 24.31. Okay, and then we're going to do the same thing with chlorine, 74.47 grams. Again, we just take that percent sign up here and made it a G, and we're going to multiply it, okay, or make your fraction table, 1 mole over our 35.45 grams of chlorine. When we do the math, okay, our magnesium becomes 1.04, okay, and chlorine is 2.10, okay, and so if we round those to whole numbers, that's 1 and 2, okay, those are going to be our subscripts. So, oh, I'm sorry, I lied. You're going to divide by 104. I forgot that piece. I was like, that sounds weird. So 104 divided by 104 is 1. 210 divided by 104 is 2. Okay, and so magnesium, sorry. So magnesium chloride, magnesium's 1, okay, chlorine's 2. We also know that we don't have to write a 1 for our subscript, okay? So there's your empirical formula. So we took our percentages, we changed them to grams, we set them up as with our molar mass, okay? We figured out the number of moles. We looked at the difference. We had 104 and 104, and we had 210. We said 104 is the smallest. We divided by that. We got 1 and 2, and those became our subscripts. Okay, so here is, we have 45.5% iridium and 54.4% chlorine. So here, what we're going to do is we're going to do the same thing. Okay, 45.5% becomes 45.5 grams. Okay, the molar mass of iridium is 88.90. Okay, so we're going to take 45.5 and multiply it by 1 mole over the 88.9, which gives us 0.512. Okay, we're going to do the same thing with chlorine. I have 54.5, and its molar mass is 35.45. We know that from the last problem. Okay, when you take that and do the math, you get 1.537 moles. Okay, 0.0512 is the smaller of the two, so we're going to divide each by that. So here's the thing, you will always have one element that is just 1. Okay, so one of your elements will always be 1 because it's the number of moles we're using. In this case, it was iridium. Okay, and then chlorine, when you divide it, you get 3. So my formula is Y1Cl3. And of course, we don't write the 1. Molecular formula is we're taking this empirical formula, okay, so the percent of each element. We have our chemical formula in its simplest form. And now our molecular is a multiple of that. So sometimes we have multiples. So for instance, you can have NO, which is uh, nitrogen monoxide, or you can have NO2, which is nitrogen dioxide. Those are two separate things, and so we can have multiples of that. Okay, it's not the simplest form. Okay, so in this case, it'd be C2O4, which is a real compound. So the empirical formula of C3H5O2, okay, that's the empirical formula. So sometimes you'll be given the empirical formula. You will always be given the molecular mass. You have to. That's just how it works. And in this case, it's 146.16 grams per mole. We're going to figure out the molecular formula. Okay. So to determine that, we have to figure out the empirical formula if we don't have it already or it's not been given to us. We have to calculate the molar mass of our empirical formula. We are then going to find N. N is the mass of our molecular, which is given to us in our problem, divided by the empirical mass that we just solved for. And then we're going to take that N and we're going to multiply it times our formula, our empirical formula, and its subscripts. So let's take a look at one. So again, my problem said I have C3H5O2, and it gave me my molecular mass. So we're going to use that in a little bit. So I have my empirical formula. It gave it to me. I'm going to figure out the molar mass. So carbon is 12.01, and there's 3 of them based on my molecular form or my empirical formula. That's 36.03. H is 5. Okay, again, that is 1.01. And here's your 5. So times 5 is 5.05. And then oxygen has 2. O, 16.0 times 2 gives me 32. I'm going to add all that together and I get 73.08 grams. So my empirical formula's mass is 73.08 grams per mole. Then I'm going to take the molecular mass that was given to me in my problem. So the molecular mass is 146.16. I'm going to put that on top. I'm going to divide by my empirical. And when I do that, I get 2. So N equals 2. And then I'm going to take my empirical formula, multiply it by 2, which means just like distributive property, I'm going to take this 2, I'm going to multiply it by 3. I'm going to take the 2 and multiply it by 5. I'm going to take the 2 and multiply it by 2. And that gives me my new molecular formula of C6H10O4. All right, let's take a look at another one. So in this case, I'm given percentages, which means I need to solve for my empirical formula first, and then it gives me a molecular mass, so I need to find my molecular formula. So I'm going to do my empirical formula first. Okay. Again, I'm just going to change my percentages to G. I'm going to use the molar mass of carbon, which is 12. Okay. And so again, to get rid of G has to go on the bottom. Think about molar conversions. Remember, you can use your table, your fraction table if you need to. Okay. And I get 7.69 moles. Okay. Hydrogen, I have 7.7%. Again, hydrogen is 1. I love when we use hydrogen. It's my favorite because really 1 times 1, or sorry, 1 over 1 is 1. 7.1 times 1 is 1, or 7.7. So I love using hydrogen. It's my favorite. So here, looking here, I have 7.69 and 7.7. I'm going to use 7.69, and when I divide it into both of them, I get 1. So my empirical formula is CH. Okay. Next, what I'm going to do is I need to figure out the molar mass of CH. So the nice thing is I already have the molar mass of each of these compounds because I needed them for my empirical formula. So 12.01 or 12 plus 1 is 13.02. Again, my problem has to give me my molecular mass. So it's 78. I take the mass of the molecular, so molecular mass given in the problem, divided by what I just figured out, which is 13.02. That equals 6. And so I'm going to take my empirical formula of CH that I solved for, and I'm going to put a 6. I'm going to distribute it out. 6 times 1 is 6. 6 times 1 is 6. So my molecular formula is C6H6. And that is all you need to know about empirical and molecular formulas.